was relatively happy. I'm not going to complain. So let's see. 1, 2, 3, 4, 5, 6 A's. 1, 2, 3, 4, 5 B's. C, 1, 2, 3, 4. Interesting. 4. Anybody seeing a pattern? 2, and then below. So, not bad. 6 A's, 5 B's, 4 C's, 2 D's, 3 below, and 2 that are still taking it, I hope. 2 show up. So, for the most part, I was happy with the test. Let's see. So, a little bit of information about the test. Points on the questions, folks. The first 5 questions were all worth 2. The next 3 on that first page were worth 3. On the second page, the first 5 questions were worth 3. The last 3 questions were worth 4. And then on the last page, 17 and 18 were worth 4, and 19 and 20 were worth 5. Okay? And that added up to a total of 64 points. So you got a score out of 64 points that I converted into a percentage. That's the score that went into Blackboard. I put it in like a half an hour ago, so should be there now. I also have all of your homework scores in there as well, so your grade should be up to date with exactly where you are right now. You should know exactly what your grade is as of essentially 75% of the class. Alright, so with all tests, folks, I like to go over it just to be safe, because essentially any one of these questions can show up on the final exam. Okay? And I will point out to you which ones are more likely to show up on the final exam versus the ones that are less likely. Okay? So, as you go through this, when I say, hint, hint, this is going to be on the final exam, you might want to put a little star next to that problem so that you remind yourself to make sure you know how to do it come final time. Alright? Alright, so number 1, what is 1,000% of 150? I do the translation technique. What is 1,000%? Convert that to a decimal. That's 10 times 150. 1,500. If you did the is over of technique, your is x, the of is 150, your percentage is 1,000, the percent always goes over the 100, and then it's just cross multiply and divide. 150 times 1,000 divided by 100, and nicely enough, you're still going to get the same answer. Okay, so either technique you use to solve these straight percentage problems, I am okay with. They both work. If you missed that one, usually because you were going too fast and didn't remember to convert things. For the second one, when it's 62, is 40% of what? Again, this time of is the unknown. It's x. 40 goes with the 100%, so 62 goes above it. Again, cross multiply and divide. 62 times 100 all over 40. 155. Scores were almost always 100% on those first 2. Not always, but for the most part, pretty close. I was happy. So then the next one was doing the House of Reps voting problem. So this is a portion equals base times rate problem. I gave you that I need 60%, so that's the rate. 0.6. And then the 435 members, that's the total number of representatives in our House, folks. So that's the base. And therefore what I'm looking for is the portion, x, what portion of those members need to vote. So this is P equals BR. 435 times 0.6, 261 yes votes. Straight portion equals base times rate. And this is actually a very legitimate question, folks. Is this how our government works right? Well, sort of works right now. If you want to pass a bill in the House, technically, if it's a constitutional bill, then it literally requires 60% of Congress to agree to it in order for it to work. And this is why we haven't had very many legislative bills passed in the last 20 years, because there hasn't been one party that's owned 60% of either House or the Senate, and they can never get anybody from the other side to vote on anything that they create, right? A Republican will never vote on a Democrat's bill, and a Democrat will never vote on a Republican's bill. So right now, our House of Representatives basically sits around with their thumb up there, doing nothing. Hopefully that will start to change. Do you think it's going to change this year, folks? Yeah, I don't think so either. But we can hope, right? Anyways, number 4 was dealing with the interest. So here I was just calculating interest. I is equal to PRT. So you just need to do principal times rate times time. The principal was the $6,000 that we invested. The rate is 3 3/4%. You needed to convert that to a decimal. Right, so it is 3.75, but it's 3.75%, which makes it 0.0375. If you made a boo-boo, that was one of the classic ones to make. And then the last one is time, 8 months. Please remember that time is always in years. You had to convert the 8 to 8/12 years. And you could not try and convert this into a decimal, because this is 0.666666666666666666666666666666666666666666666666666666666666666666666666666666666666666666666666666666666666666666666666. You get the idea. You needed to use the fraction, okay? And when you multiply this out, the nice thing about it is that it works out to be exactly $150. If you tried to use a decimal representation of this 8/12, you wind up getting pennies at the end, then you get a rounding error, and you lose points. Okay, so please learn how to work with fractions, folks. You can guarantee that there will be something like this on the final exam where you're going to have to multiply by fractions. And if you try to convert it into a decimal, it's not going to work. I can almost guarantee you there will be at least one, if not 2 questions on the final exam like that. Okay? I mean, I know I'm being a bit of a dick about it, but deal with it. Okay? You have to learn how to deal with fractions, or I'm going to be mad at you, or you're going to lose some points. I mean, that's the way life works. All right? Alright, so anyways, and then the last one was getting a discount, a 15% discount on a $82 pair of shoes. $82.26, must be female shoes. I don't spend that much on shoes. Women, you guys get screwed when it comes to shoes, right? I mean, I've never seen a pair of women's shoes less than $80. Unless they're like used or something, which is weird. Oh no, I can find cheap basketball shoes too. I mean, these are $60, right? And that's because they don't make them very much anymore. I have to order them from Zappos, and I order them 5 at a time, 5 pairs. Because I've worn the same pair of shoes, folks, literally for 28 years. When I graduated from college, I bought my first pair of these shoes, and I have never bought another pair otherwise to do official functions in. Right, so when I go to work, this is what I wear, always. When these wear out, I grab the next pair, because I've got at least 3 or 4 boxes in reserve always. Pull it out, put them on. These become my wear around the house shoes, and I throw the other pair away. And I cycle through forever.
Same colorway?
Yes, exactly. Always. I never get anything other than brown. Sometimes it's a little bit darker. It's awesome, right? That's the way to have shoes, right? I have 1 pair of shoes, unless I'm playing sports, and then I have whatever. Right? But otherwise, this is the shoes I wear all the time. All right. So, anyways, the idea here, folks, is that you're going to take 15% off of your shoes to figure out how much it costs, and if it's 15% off, folks, what percent did you pay for? 85%. So the other way that you could do this to do it faster is just do 8220 times 85%, because that's how much you actually paid. You paid 85% of the price. $69.87. Either way, if you did the multiplication by 15 and subtracted, it worked just as well. It's not like it didn't work. It's just this was the easy way of doing it. All right. So, for the most part on those first 5 questions, it was pretty much hit or miss. All right. You either got 2 or you got nothing. That's the way it worked most of the time. There are a few instances where a couple of people got 1 on some of those, but those were rare. All right. So. That was the first column. Now the next column. Number 6. The air conditioner's marked up 25%. The new price is $400. Find the original. This, folks, is one of these problems. New equals old plus rate times old. This is a markup. If you subtracted to get this answer, folks, you are guaranteed to be wrong because it's a markup. Markups are only plus. Right? And here I have given you the new price, $400. Do I know the old price? No, so I call it X. What's X plus 0.25X? 1.25X divided by 1.25. $320, because a fourth of 320 is 80. 320 plus 80 gets you to 400. If you try to work 300 and make it work, it never will. Right? You can't take a quarter and subtract. Folks, this is going to be a question on the final exam. Okay? Almost a guarantee. Now, on the final exam, it may be a percent decrease problem, where I tell you you had a 40% off coupon and the new price is $38. What was the original price? But you're doing a decrease instead of an increase. Remember, then you subtract instead of you add. Otherwise, I mean, this question, this is one of those classic ones. I ask it in almost every final exam of every class that I teach. Doesn't even matter, right? If it's intermediate algebra, I still ask this, right? If it's statistics, I still ask this. Because you should know how to do this in any math class that you take, period. Right? Unless you're in 3rd or 4th grade still. Right? Once you get to 6th grade, you should do this question every year for the rest of your life. Or until you're done school, right? And hopefully by then you'll have remembered how to do it all the time. I think that's why we don't remember, is because not enough math teachers pull out the whip and crack it at you every time for this problem. Because you should do this all the time. My opinion, of course. Alright. So number 7 is figuring out a percentage increase. Again, this is another question that you can pretty much assume is going to be on the final exam as well. Some sort of a percent change problem, okay? So, the way you do a percent change, folks, is that it's always the difference divided by where you started. And that start problem threw people for a couple of loops every now and then. So 45,000 minus the 22,000. Where did my salary start at? The 22,000, because it's going up, right? It went up from 22 to 45. So this is going to be 23,000 over 22,000. And when you punch that into your calculator, you get 1.0454545454545, etc. I had a lot of people who told me that that's a 1.0% increase. This is the decimal representation. To make it a percent, what do I got to do? Move the decimal point over to 104.5% increase. And that, why does that make sense, folks?
Because you gained more than 100% of your salary.
Yeah, my salary more than doubled, right? 22,000 doubling would go to 44,000. That's a 100% increase. When you double your salary, you're gaining 100% of your salary. If you more than double, that means you have to be more than 100%. Here it is, just a little bit more than 100%. All right? That kind of mathematical analysis, folks. I want you guys to do when you're looking at the numbers. Don't just grab a formula and go chunk, 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 right? Make sure that when you're done with it, you look at it and say, does it make sense? You guys should be able to think about 100% and know what it means, all right? Because you told me at the beginning of the year that 100% is the same as 1. Okay? So, again, this one is another one of those things that piss me off when you don't do it right. And enough of you did not do it right that it did piss me off. So, you will see this again. Okay? That's a guarantee. All right? So, again, put a nice star by this one because you will see it again. All right. So, number 8. This one was the future value problem. So the number I gave you is A, the 85, 52, 70. That's how much I'm going to have in 2 years, right? A is always what you're going to have in the future, so in 2 years I'm going to have that much. My R and my T, and again, convert your percent to a decimal correctly. And then it's just a matter of plug and solve, right? So 85, 52, 70 equals P times 1 plus 0.0225 times 2. Had a couple of boo-boos from people who couldn't seem to do that one. Lost decimal places a couple of times. To get P by itself, divide by the 1.045, and you'll wind up getting a principal starting value of $8,184.40, rounded appropriately. I tend not to ask this one on the final exam, just so that you know. Future value. Alright, so that was page 1. Page 2, converting. So 8.45 hectometers. Convert them into millimeters. We need the hectometers on bottom, millimeters on top so that they cancel. Which one's bigger? The hectometers, therefore it gets the 1. How many hops to millimeters? 5. So 5 zeros. Or move the decimal point 5 places, and since you're multiplying, you move it to the right. $845,000 millimeters. Again, 3 points for these ones over here on the left-hand side. The annoying one, cups to teaspoons. So if you've got 1 3/4 cups, how many teaspoons do you got?
48 teaspoons.
Yeah. Just go through the different conversions, right? 1 cup is 8 ounces. 1 ounce is 2 tablespoons. And 1 tablespoon is 3 teaspoons. Just turn the crank through each and every one of them, right? So multiply it all out. There's your 84 teaspoons. Again, that's my one to make sure that you can do multiple conversions all at the same time kind of thing, right? But nothing fancy going on there, no rounding you had to worry about, so that made it relatively nice. Alright, then the next one, 891 yards, converted into miles. There were a couple of people who knew exactly how many yards there were in a mile and just used that straight conversion. Perfectly fine if you did that. I'm going to go to feet instead, so 1 yard is 3 feet, and then use the number that I do have to work with all the time. 1 mile, 5,280 feet. So take 891, multiply by 3, divide by 5,280. 0.50625 miles. And note, folks, that all of these conversions are exact. When the conversions are all exact, you keep all of your digits. Okay, so no rounding when these things are exact. All right. So if you got 5 or 6 decimal decimal places, just give them to me all. The only time that you round this is if one of these conversions tells you, hey, round. Alright? And that's only switching between units. Alright, then number 12, another metric one, 9.45 kiloliters. Into decaliters. Decaliters, there's 2 hops from kilos to deca. So 2 zeros, hop the decimal point 2 spots, 945. Alright, again folks, on the final exam you'll definitely have units that are weird, like hectometers or decimeters or, decaliters, whatever. So make sure that you know the 7 different prefixes for dealing with the metric system. Alright, not too bad? Again, you guys were pretty good on those, so 13, working with the acres to square miles. So the key to this one is that there are 640 acres in 1 square mile, and the square is already built into the conversion, so you don't need to do any squaring. This is one of those where it's straight up, just multiply these across and you're done. So when you multiply it across, it turns out to be 0.2 square miles. So when the conversion has the square, you don't have to do it. It's when it doesn't have the square, but you do, that you have to. Right? Alright, then the next one. So 53.5 centimeters. To yards. Now there were a ton of different ways to do this problem. And each one of them has a slightly different answer, but they all base from the same number. Alright, so one way of doing it was to say, hey, in 1 foot, there is 30.5 centimeters. And then you have to convert those to yards. Right? Yeah. 1 yard is 3 feet. So take 53.5, divide by 30.5, and then divide by 3. And you get this number, 0.58469954. How many of those digits do we get to use, though? That is our one approximate conversion. So you only round based on what you're converting from, right? This is 3 digits, so this is going to be approximately 0.585 yards if you use this conversion, okay? Only if you use that conversion. If you used a different conversion, so let's suppose you use the 0.91 yards per meter, right? So you said in 1 meter there are 100 centimeters, and then you said that in 1 yard there are 0.91 meters. This is also a perfectly valid way of doing the problem. If you wanted to do it and you did it this way, perfectly okay. When you do this, you get 0.587912088. But now, since I used a conversion that only has 2 digits, I have to round my answer to 2 digits. So if you use this conversion, you have to have that answer, okay? And that's why I had to see your conversion when you were doing these problems, because otherwise I don't know whether or not you gave me the right answer. Because if you used a different converting factor but didn't have the right number of digits for it, I have no idea, right? And again, you could get carried away with this problem. There were a couple of people that went down that road. So you could have said, well, there is 1 inch in 2.54 centimeters, and then in 1 yard there are 36 inches. And this is 0.585083115. 1 inch, 2.54 centimeters. This, folks, is exact. If all of my conversions are exact, what do I do with my digits? Keep them all. right? So if you left your answer like this, that was perfect, right? If you used 2.54, folks, you had to keep all of the digits, all right? If you rounded it when you used 2.54, then you were cheating. You're cheating yourself out of having more accuracy. You have all of this accuracy if you use 2.54. I did have one person, well, maybe even more than one person, who told me that this was really 2,675, 4,570 seconds worth of yards. That's the exact answer, folks, as a fraction. That got you extra credit. There were at least 2 people that did that, which was cool. I was like, yeah, sweet. Right? Again, though, that's a little overkill. And I think there was even one person who converted this to kilometers and then went from kilometers to miles and then went from miles to yards. And then since they used the kilometer conversion, they got 4 significant digits and they had to round to another number. Again, all of those are valid ways of doing it, and all of these answers are valid based on the way you did the problem. Okay? This is where math starts to be a little bit like English, where you can have a different answer and still be correct, right? That's totally the way all of our social sciences work, right? As long as you argue your opinion is correct, right? So math gets to be like that every now and then. Yay! Or no, boo, right? Because it's much nicer when there's only one answer, right? And you don't have to worry about it. Me right? Yeah, so when you get these math things where there's like life happening, you're like, ah, shit, why isn't math just math, right? Anyways. Alright, so that one was sort of fun. Well, for me anyways. Alright, and then 15, converting cubic feet into cubic yards. 3 feet in a yard. Again, though, folks, you had to cube that. If anybody had a problem with this, it was usually because they told me that 3 cubed was 9, because you did 3 times 3. 3 cubed, folks, is 3 times 3 times 3. It's 3 3s. That's 27. But it does work out to be a nice number. Straight up 3.7 cubic yards. That's the only right answer for that. And then last but not least on this page, the miles per hour to feet per minute or meters per second. 40 miles per hour. So you have to convert the miles and the hours, right? 1 mile, 1.609 kilometers. 1 kilometer has 1,000 meters. And then last but not least, make sure you convert the hours to per seconds. In 1 hour, not 60 seconds, not 360 seconds, but 3,600 seconds. There are a couple of people that made a couple of boo-boos on that one, floating around. And when you do this, you get 17.877777777777. Lots of sevens. 4 digits because of this conversion. So that the answer here, 17.88 meters per second. And again, if you switched to, yards and then used centimeters and used the 30.5, you would just have to use 3 digits at the end because you used a less number of significant digits conversion. Perfectly okay. Answer would be slightly different, but basically sitting right around that 17.9 spot. Folks, this is a very classic problem. All right, going from miles per hour to meters per second. That's like every physicist's day 1 class type of question. All right. So do not be surprised when I ask you a variation on this theme again on the final exam, okay? There's definitely going to be some kind of a rate problem, and it's probably going to be something like this, meters per second to miles per hour, or vice versa, okay? Usually, folks, if I did it one way on the test, I will reverse it for the final. So on the final exam, I'll tell you something like, I'm going 50 meters per second. What's that in miles per hour? So, same question, but going backwards, right? Alright, so, anyways, that was the end of page 2. And then the rounding off, page 3, number 17, 25 feet squared, converting it to meters squared. This one's just being careful with the squares. That was a bigger problem more than anything else. So if you use the 30.5 centimeters in a foot, you had to remember to square it, right? Since these units are squared, but neither of these are, you have to square the whole thing. And then don't forget that I want to get it in meters. So there are 100 centimeters in 1 meter. And again, you still have to square everything. People, if you made a mistake, it was usually because you squared one of them, but then forgot to square the next one, whichever one you did next. Punch this out. You got 2.3256525. If you use this, you get 3 digits. So you're going to have to round this to approximately 2.33. What's I doing in square meters? And again, whichever conversions you were using, right? I definitely had a lot of people who went the route of yards, right? They said, hey, I know that there's 3 feet in a yard. In fact, a lot of people just wrote, I know in 1 square yard there are 9 square feet. Perfectly okay. And in 1 yard there are 0.91 meters. Again, you still have to square all of that. When you punch that out, you get 2.322576. And now because you use the 0.91, you only get 2 digits. 2.3 square meters. And again, there were a couple of people who went the full blown out, convert this into centimeters, use inches. And again, the numbers were just a lot bigger. You get to keep all of the digits when you have centimeters to inches because it's exact, etc. Okay? Again, we could play this game lots and lots of times. I won't overkill it on you though. Just realize that there can be multiple answers. And then the last conversion one, 275 cubic centimeters converted into cubic millimeters. Centimeters, millimeters. The key, of course, is that that's 1 hop, 10 millimeters in a centimeter. You still have to cube it, though. 10 cubed is 1,000, so 1,000 times 275. 275,000 cubic millimeters. All right? So those are your conversions. All right? And again, the final exam will probably have 4 of these. 1 rate, 1 square, and then usually 2 regular ones otherwise. Okay? Either a square or a cube, depending on how I feel. So, be ready for those. There will be one of these last 2 on the final exam as well, folks. Okay, so please figure out how to do 19 and 20. So the way 19 and 20 work, folks, is you got 1 point for getting the right units. You got 1 point for writing out the number correctly. And then you got 3 points for rounding it to the right spot. Alright? So 74.15 meters times 0.8016 meters minus 2.20 square meters. So if I saw this number somewhere, 23864, that got you 1. Right? But now you have to figure out, where do I round this at, right? Okay, so the key is, remember, the first thing you do is multiply these 2 numbers, because multiplication comes first. You get 59.43864. Now, how many of those digits do I get to keep? Since I'm multiplying, this is significant digits. This has 4, this has 4. I get to keep 4 digits. Okay? You don't have to round it or anything. All you're doing is figuring out where you are. Right? And then I'm subtracting 2.20 meters squared. When you subtract, folks, you don't count significant digits. Okay? Adding and subtracting is precision. That's where you tell me, where does the number stop? This number stops at the hundredths. this number stops at the hundredths. So where am I going to round my number to? The hundredths. Okay? So no matter how many digits there are, we don't care, because at this stage we're doing addition or subtraction. That doesn't matter significant digit-wise. So what we do is we're going to round to the hundredths over here. So this is going to be approximately 57.24 square meters. And if you rounded it one number off, I took off 2 points. If you rounded it 2 numbers off, so if you told me it was 57 square meters, then I actually took 3 off. All right? So, 1 point for the number, 1 point for the units, 3 points for being in the right spot. So, now the other way, when you have to do the addition first, right? So 22.5 centimeters plus 89.22 centimeters times 0.0896 centimeters. So when you punch that out, you get 10.010112. Again, note there are parentheses around this addition, folks, so therefore you add first, then multiply. I had a few people who were just multiplying these two numbers and then adding the 22.5, and that was bad. But anyways, okay, what do we do first mathematically here, folks? Because it's in the parentheses, we do the addition first. Since we're doing addition, we say tenths and hundredths. So when I add these two numbers, what do I get again? 111.72. Technically, where do I round it at? Tenths place, right? And then I'm going to take this number and multiply by 0.0896 centimeters. Now, how many significant digits are in this number? Again, remember, we've thrown that digit away. I have 4 significant digits. How many significant digits are in this number? Right? Remember, that leading 0 after the decimal is not significant, right? Therefore, there's only 3 significant digits here. If you're doing 4 significant digits times 3 significant digits, your answer can only have 3. Therefore, this is approximately 10.0 square centimeters, because here we're taking centimeters times centimeters. Centimeters times centimeters gives you centimeters squared. Okay? So, that one's a little on the tricky side, but that was more me putting this number over here to make sure that you guys remembered how to count your significant digits, okay? Do not be surprised when the question on the final exam has this kind of a number in it, right? Where you're going to multiply or divide by it, and you need to know there's only 3 significant digits, okay? So, be ready. And that is, again, a non-subtle hint for the type of question I will ask on the final exam. All right? All right, so that's test 3. All right, so put that away. Don't lose it. Keep it so that you can use it to study for the final exam. My advice, folks, by the way, to study for the final exam is redo all the tests. Because honestly, that's how I write the final. I go through the tests and I say, oh yeah, I like that question. I remember. I'll type up essentially the same question, or what I'll do is copy and paste and then change 2 or 3 of the numbers, right? And that's the way most lazy people do things. Right? All right, so Unit 4, folks. Geometry and trigonometry. So the last thing we have to do this semester is to go through what we are going to know or do with geometry and trig. All right? So things that we are going to do in geometry, we are going to work with angles, triangles, quadrilaterals. What's a quadrilateral, guys?
Four-sided.
Four-sided. So what's the classic quadrilateral?
Square.
A square, right? Or a rectangle, or a rhombus, or a parallelogram, or a trapezoid. You guys will learn what all 5 of those words mean. Okay? So, you will also be able to deal with perimeter, area, and volume. Not volume, but volume. And I suppose I should tack onto this surface area, which is the area that is enclosing a 3-dimensional object or some sort of a volume, right? So we'll go through some basic calculations of dealing with perimeter, area, volume, and surface area. And it's mixed in and around there, folks, but don't forget that there's a Pythagorean theorem. That's kind of all over the place in this unit is Pythagorean theorem. So we're going to do that in trig as well as in geometry. So you get it twice, just to make sure that you get it. That's another one of those classic ones that you should really know. All right. So in the trig, you're going to know how to deal with right triangles. So again, this is more Pythagorean theorem. And then you're going to learn how to use sin, cos, and tan. And it's not sin, cos, and tan. It's sine, cosine, and tangent. Okay, these are trigonometric functions. Had a student one, this is like 4 or 5 years, well, more like 8 or 9 years ago now. When I was first starting to teach this class, and we started talking about sine, and I said, well, guys, hit the sin button on your calculator. And the student in class was like, well, I'm not going to hit any button that's called sin. And I was like, what? He's like, well, I'm not. That's sinful. Why would I hit something that's got sin on it? I was like, At first I thought she was joking, right? So I was like, well, but it's funny though, isn't it? It's sin, right? And then there's the little button above it that's called the inverse of sin. That's like the prayer button. So you can hit that one instead. How does that make you feel? It's like, oh, that's much better. But it doesn't say prayer on here. And I was like, what? Why? No, it's not sin, folks. It's sign. Okay? Just so you know. All right. So note, folks, that we are only going to be doing this in a right triangle. We will not do any kind of sines and cosines or tangents in an oblique triangle. You don't get to learn the law of sines or the law of cosines. They took that out. Apparently, in the real world, there is no such thing as a triangle that is not a right triangle. So, if you own anything that is not a right triangle, according to this class, you're supposed to throw it away. Or not have to worry about it, apparently. Whatever. I just do what I'm told. I was told to deal with trigonometric functions in a right triangle only, and so that's what I do. Okay.
Yeah, yes.
I agree. Whatever. Anyways, this is what we're going to be doing next, all right? So, we're going to start with geometry. I just want to go ahead and get us started. Just go through the really basic stuff. I don't want to get far enough that I have to assign any homework, because I haven't made the homework assignment yet, and therefore I wouldn't be able to give it to you anyways. So we're just going to do like 15 or 20 minutes of the preparatory work for geometry, and then we'll call it a day, okay? We'll leave a little bit early. All right, so geometry. With most things, you're going to start with terminology, just so that you can kind of be used to the words that I'm going to be saying when I'm talking geometry. So, I will constantly be talking about dimensional analysis or dimensions in space, all right? So we got to start at the beginning, right? And for a mathematician, 0 is where you start everything, all right? So in geometry, we have one-dimensional object that is zero-dimensional, okay? The zero-dimensional object for us, folks, is a point, okay? So if you were asked to describe a point, you can just say it is the zero-dimensional object, okay? Not that that's important. I'm not going to ask you that kind of crap, but this is just to set the table, all right? So if a zero-dimensional object is a point, what is a one-dimensional object? What's your guess?
A line.
A line, yes, exactly. All right, so lines. Think the number line, folks, right? When we graph things on the number line, we're graphing things in one dimension or one variable, hence a line. Now, when I say the phrase line segment, what does that mean, folks?
Where lines cross.
On the right track, but not quite. Points between two defining points. So a line segment, note folks, lines are always an infinite number of points. Every line is an infinite number of points, okay? Whether it's a line segment, array, or a regular old line, it's technically a set of infinite points. But the idea is that a line segment is just the points between 2 points, okay? So if I had up here point A and point B, the points that are between A and B is the line segment of A and B, okay? And line segments, folks, you have the 2 points A and B in your description, and then you put a line over it where it's just a line to indicate that it's a segment, okay? Now, array is also a one-dimensional line, except it's a slightly different line, okay? It's points between 2 reference points, or 2 defining points. If I'm saying that, I should be consistent. And all points in one direction. So array is a one-directional line, and it's just grabbing all of the points in one direction of the line segment that you get. So if I define, let's do this in red, array AB, and note how it differs, right? If you have array, you're going to put one arrow along the top, telling people that it's going in one direction infinitely, okay? And this is a very special type of array that starts at A, goes through B, and goes on infinitely afterwards, okay? So array AB looks like that, right? Starting at A, going through B, but then going forever, okay? And note that it's slightly different if you change the order of the points, right? BA is array as well, but it's a different array. Because now where am I starting? At point B, going towards A, and going in the other direction, right? So there are some points that are the same in both of the arrays, but then there's a lot that are not, okay? So again, just realize the notation. That's more of what I'm trying to get across here. And then last but not least, a true line. Is basically the 2 rays put together, okay? It's all the points between 2 points and going in either direction out the end of the line segment that you built, all right? Goes off in both directions. And again, that's why you put double arrows along the top, okay? And it's more just so that you can see this notation and know what people are trying to tell you when you see it, okay? You're not going to have to know this kind of crap for this class, okay? I'm not going to ask you what does this, what does this symbol represent? Is it a ray, a line, or a line segment, right? I'm not gonna ask you stuff like that, but I want to get you to at least see it once, so if you see it again, you don't freak out and go, whoa, I've never seen that crap before, and I supposedly got geometry once, right? This is just me giving you some background, alright? Alright, so, the things that we will be dealing with in this class. Okay, so we've now sort of done the prep work. Angles. What's an angle? How would you describe it using the stuff that we just talked about a little bit ago? I mean, what does an angle look like, first of all? Is that an angle? Alright, good. So it's two lines intersecting at one point, and I'm going to even be more picky than that. I'm going to say two rays that start at the same point. Okay? So an angle, by definition, is two rays with the same starting point. That's what defines an angle. So if we've got a starting point A, we can have a ray going one direction, say towards B, and we can have another ray going towards C, and those two rays, since they both start at the same point, define the angle CAB. All right? Note, this is a little weird less than symbol, folks. It's also it looks like the picture of an angle. That's how you start to represent an angle in text. Okay? Is that little weird symbol? It's a standard ASCII character. You can look it up. It's like ASCII code number 785 or something like that. It's one of the extended versions. And note, when you write an angle using points, the middle point is always the vertex, or the shared point, okay? So this is not angle ABC, okay? Angle ABC would be starting at A, going to B, and then going to C, which is a slightly different angle, okay? So just realize how you name an angle so that when you have to use them, you know what it's being talked about, all right? And then what you do, if you put a little M in front of the symbol, guess what M stands for? Measure of the angle. Alright? You see a little M in front of it, that's just how you get a measurement in degrees, right? So you say something along the lines of, hey, the measure M of angle CAB is 40 degrees or 41 degrees, whatever that works out to be. All right? Please note, folks, that you will not have to use protractors and compasses in this class. Okay, so none of that crap you did back in your geometry class in high school if you had it. So you're not going to have to draw stuff for me using a protractor and a compass. That way, way, way outside the scope of what we're trying to do here. All right? So do you guys know any special angles that might have a special name?
Obtuse.
Well, that's talking more along. We'll get there. We'll get to that one. What's the most classic special angle?
90 degree.
Yeah, 90-degree angle. What do we call those? Right angles. Okay. Right angles, folks, are just angles with a measure of 90 degrees. Degrees. So now, and again, the idea here is pretty straightforward, right? Here's A, here's B, here's C. And notation, folks, that's standard notation on an angle to indicate that it is a 90-degree angle, okay? you ever see an angle that's got a little box drawn in the corner, that's basically the way a person is telling you that that angle is a right angle. It's exactly 90 degrees. Not 91, not 89, not 89.9 or 90.1. It's exactly 90 degrees. All right? Now, another special one is a straight line angle. The heck does that mean? I'll give you the definition. Angle with a measure of 180 degrees. What does that mean about the angle?
It's not really an angle, it's just kind of a straight line.
Yeah, it's not really an angle, it's actually a straight line, but it can be defined as an angle, right? So if you've got A here, and here's AB, and you've got C over here, AC, it looks like it's just a regular old straight line, but because you've got this ray and this ray that start at the same point A, this angle is 180 degrees. Okay? Please note that technically when you measure an angle, you always measure it counterclockwise, folks. It's a little weird, but that's just the way life works. The reason that you do that is because of physics. If you know anything about magnetic and electric fields, you use right-hand rule. So if you assume the magnetic field is coming out of the board, the electric field is going to be rotating this direction counterclockwise. That's why they do it, all right? So angles will all be measured in the counterclockwise direction. Nitpicky point, but just so you know. All right? And now, Brandon,
Obtuse.
let's do acute first.
Okay.
What are acute angles?
Angles less than 90 degrees.
Yeah, angles less than 90 degrees. Angles with measure less than 90. Please note, strictly less than 90. And then the other side of the coin, the obtuse triangles, or obtuse angles. Angles with a measure more than 90. More than 90 degrees. So, again, these are just terms. Again, I'm not going to ask you about these two terms, but they're great Jeopardy questions. If you ever take Jeopardy, if you ever have to do Jeopardy and they're going to ask you about geometry, I can guarantee you one of these two words will be used. This always is. Alright? Alright, so, let's see. Oh, I remember. Complementary angles. What does it mean if an angle complements another angle? It does not mean that it looks over and goes, oh, you have nice lines. Right? That's not the sort of thing that it would do. All right, this is just two angles that have sum of their measures equal to 90 degrees. In other words, if you put the two angles together, they make a right angle. Put the angles together and they make a right angle. And so you should be able to do things like, if I draw this, if I say this is a right angle, and I say, oh, this is a 28 degree angle, and I say find x. How would you find x in that picture?
You subtract 90 and 28.
So use that complementary concept to say, this is how I can figure out what another angle is, okay? And again, I can put other kinds of things in here, like 2x minus 1, and this could be x plus 12, and you would have to use that to solve for the angles, okay? Common sort of thing to do where I force you to do a little bit of geometry and a little bit of algebra, which is always good, all right? So, complementary angles make a 90-degree angle. Guess what supplementary angles create? Straight lines, exactly. Angles whose measures add to 180 degrees. So what if I told you that this angle was x plus 10, and I told you that this angle was, let's see, make it so it's not too painful, 3x plus 70. And I said, find the measure of these two angles. How would you do it?
Plug in 180.
Be careful. What do you got to do, folks? Add them and set them equal to 180. Right. So since these are making a straight line, we know that the sum of the two angles have to be 180 degrees. So you just say, no, 3x plus 70 plus x plus 10 equals 180 degrees. Okay? And now you have to do some algebra. Do you think that that would be the sort of thing that I would like you to do? Duh. Right? You guys, I will continue to try and throw algebra at you forever, because that's part of the class as well. So, solve. How would I solve this? What would you guys do? Combine like terms. Great. So what does the left-hand side become? Four x's. You've made some bad life choices. What are you going to do to solve that?
Subtract the 80 divided by 4.
Subtract the 80. Divide by the 4. Please don't stop there. If you tell me that x is 25, I'll say, gee, great, thanks. Here's half your points. What did I ask for? Measures of the two angles. What are the measures of those angles up there, folks? Plug it in. What is 25 plus 10?
35.
This is a 35-degree angle. What's the measure of the other angle?
145.
145 degrees. And you can figure that second one out either way you want. You can plug 25 in here and calculate it, or you can say, hey, this is a straight line. I know they add up to 180 degrees. What's 180 minus 35? 145. Either way, okay? So, again, definitely will be something like this on the test, forcing you to do some algebra with a little, small bit of geometry knowledge. One last topic, then we'll call it a day. Vertical angles. Vertical angles are created by having intersecting lines. Created by intersecting lines. So this is not rays, but truly lines. So when you have a line, and you have another line, how many angles did those lines create? 4. There are two pairs of vertical angles. Guess what the vertical angles are going to be? Yeah, the ones across from each other. And the reason I like to do this is the notation piece here. Note how you mark an angle. It's the same sort of thing you do with lines in a picture. If you want to say that two lines are the same length, you put one slash through the lines and say, oh, these are both the same length line. You do the same thing with an angle. You put an arc across the angle, and however many slashes you have on the arc tells you when things are the same. So these two are the same because they have 1. These two are the same because they have 2. All right, that kind of concept. Now, just so that you get the snootiness of geometry, this is the phrase that a geometry person would use to talk about vertical angles. They would say, and in the most haughty voice that they can think, vertical angles are congruent. And they would say it in such a way that you can tell that they're looking down their nose at you and kind of going, oh, duh, how come you didn't know that? Right? What it means is that opposite angles are equal. That's the English translation of the geometry snobbery. Okay? Opposite angles are equal. And that's why these two angles are the same, because they are opposite of each other. That's why these two angles are the same, they're opposite of each other. Okay? So, if you ever hear someone call it a vertical angle, 1, slap them. And then 2, remember that it just means opposite angles. Okay? And they're the same. Alright, that's enough for today. We didn't get far enough to do any homework, so there's no homework. I will get the homework assignments to you next week. We'll go from there.